Welcome to this introductory video on trigonometry. In this video we're going to look at finding unknown side lengths of right angled triangles. Okay, we have the trig ratios, the trigonometric ratios, sine, cosine and tangent, defined in terms of opposite, adjacent and hypotenuse. The hypotenuse of a right angled triangle is the side that is the longest, and it's the one opposite the right angle. Okay, the adjacent is the one next to the angle that you're concerned with in the question, and the opposite side is the one furthest away from the angle you're talking about in the question. All right, so let's do some examples. The first one here says that we have a side length z to find. Okay, and we notice that regarding the angle of 25, z is adjacent and 9 is the hypotenuse. So we start by writing a trig equation, and that is that z over 9 is the adjacent over hypotenuse, which is the cosine of 25 degrees. So that's the cos of 25, okay? So from that, we can say that if we multiply both sides by 9 cos 25 is z. So z equals 9 times the cosine of 25, okay? Now, when we put that in the calculator, we must make sure the calculator is in degrees, and there's usually a D in a box along the top of the screen. If you've got an R or a G, then it's not set up correctly and you need to reset it to degrees. Put that in the calculator and you get 8.16 to 3 significant figures. So 8.16 centimeters. Now, just have a look at the diagram before you move on to the next question and check that it seems about right, okay? Because this is a good way of seeing that it could or couldn't be right. Now, if this is 9 and it's the hypotenuse, it's quite reasonable to expect z to be a little bit less than 9, and that seems to fit. If the z had worked out to be more than 9, then you know something's wrong and you need to go back and check what you've done. Okay. Now, in the second one, we're asked to find the length p, and we notice that p is opposite and 11 in this one is the adjacent. So I've got p over 11. Okay, p over 11. And opposite over adjacent is the tan of the angle. So it's the tan of 20. Okay, rearranging that, I get that P is going to be 11 times the tan of 20. Okay, and if I put that into the calculator, that will give me 11 tan 20, okay, and that comes to 4.00 to 3 significant figures. It's actually 4.003, but we put 4.00 because we're asked to give it to 3 significant figures, also in centimeters there. Okay. Now, this one, you just need to be careful and you'll see why in just a moment. Now, on this one, we're asked to find x, which is the hypotenuse, and we're given the opposite, which is 18. So my trig equation would say that opposite over hypotenuse, so 18 over x, okay, 18 over x is equal to the sine of 41. Okay, now notice this time that the unknown is on the denominator of a fraction. Okay, here it was on the numerator, here it was on the numerator, and this time it appears on the denominator. So we have to follow the usual steps of solving equations, but there's an extra step here because I need to multiply both sides by x. So I get that x times the sine of 41, okay, equals 18, okay, and that means that x is going to equal 18 divided by the sine of 41. Okay, and this is where people go wrong because they end up multiplying them together, but you need to be careful by just following the normal steps of solving an equation, you see. So you put that now into the calculator and see what that gives you. So it's 18 divided by sine 41, and that gives you 27.4 to 3 significant figures. Okay, 27.4 to 3 significant figures, centimeters. Okay, now coming across to the other side, let's do this one here. We've got two unknowns here. We've got G and H. So let's start with G, and if we look where G is, we're given the adjacent, G is the opposite. So I can say that G over 6, that's opposite over adjacent, is the tan of 62. Okay, that means that G is equal to 6 times the tan of 62. So this is a straightforward one where we're multiplying, and if you put 6 tan 62 into the calculator to 3 significant figures, you get 11.3 centimeters. And that seems a reasonable answer for that question. Okay. Now we're going to find H. Now this time we've got the adjacent is 6 and the hypotenuse is H, okay, and adjacent over hypotenuse is cosine. So I can say that 6 over H, okay, 6 over H is equal to the cosine or the cos of 62. Okay, now multiply by both sides by H, because again the unknown is now on the denominator. So I know that H times the cos of 62 would give me 6, and therefore I have to say that H equals 6 divided by the cosine of 62. Okay, and if I put that into the calculator, I will get 12.8 centimeters. Okay, 12.8 to 3 significant figures. I've rounded all these already. Okay, and the last one is we've got two to do here, E and F. So if we look at E first of all, I can say that E over 14 is opposite over adjacent, because F is the hypotenuse. So E over 14 is equal to the tan of 12 degrees. Okay, because it's opposite over adjacent. Okay, and that's going to imply that E is 14 times the tan of 12 okay, and that comes to 14 tan 12, 2.98 centimeters. Okay, 2.98 centimeters to 3 significant figures. Now, if you think about that, 12 degrees is quite a small angle, and so it seems reasonable that if that's 14, this is actually quite short. Okay, and that's just under 3 centimeters. Okay, so it seems quite reasonable. But bear in mind that the diagrams in these sorts of questions are very often not drawn to scale. Okay, and that's deliberate really, because it forces you to calculate and really think about what you're doing. Finally, angle F, we can say that F is the hypotenuse and 14 is the adjacent. Okay, so it's cosine, and we've got the unknown underneath the fraction again. So 14 over F is the cosine or the cos of 12 degrees. Okay, rearranging that, we're going to get that 14 equals F cos 12, or F cos 12 is equal to 14. Okay, and rearranging that is going to give us that F is 14 divided by 12, by the cos of 12. All right, so 14 over cos 12. Okay, and then you put that into the calculator, and out comes 14.3 centimeters. Okay, it's about 14.31 on the calculator. So just look at that. Now that's very close to the length of the hypotenuse. Okay, the hypotenuse is slightly longer than 14, but you would expect that, but you wouldn't expect it to be much longer because of the shallow angle here. All right, so it does seem about right. Okay, so that is an introduction to finding the lengths of sides, of unknown sides in a right-angled triangle. In the next video, we will look at finding unknown angles using trigonometry when you have sides given to you, and that will be in the next one. Hope that was helpful. Take care.